So I wanted to introduce Dave. I'm Bill Hurd. I'm from part 2 of Commodore, which I like to think of as a Greek tragedy in 3 acts. Here's our 3rd act, Dave coming. The reason I wanted to introduce him is I was the first person Dave met from CBM, and I was also the first person to know he was about to be hired by CBM. So what we used to do back then is we would go to, you'd work all day, work hard, and then go to the headhunters until about 10 at night, and they would just run all these people by us. So on one night, me and my boss, Joe Krasuki, go there. They're putting him in the back, and I'm sitting out front in the waiting room. And in bops this guy. And I mean, he had diddle-bopped in the door. He had all this youthful energy, hadn't burned him out yet and everything. And he's wearing a homemade shirt. So you figure anybody that makes his own shirt probably knows how to solder, too. So he sits down next to me. He's going, "You here for the job?" And I'm like, "Something like that." That's exactly what I said. So then I'm like, I've got the magazine upside down or something. I'm like, "So where are you working now?" And he's, "Oh, I'm GE." "So why are you quitting?" "Oh, I don't like killing people. I'm writing missile code." Well, if somebody said that to you in an interview, you'd be like, "Really?" But he's telling me this in the front lobby of a headhunter. So at some point, he goes in, gets interviewed, and then he comes in to interview with me, and the look on his face is priceless as the long-haired guy sitting there said, "We've met." So the one thing about Dave, see, I'm a self-taught guy, ex-TV repairman, everything. I'm really bad at math. I'm from Indiana. We don't do math in Indiana. And so what I needed was somebody that could do the things I couldn't do. So the final test I had for Dave was I said, you know, "Can you do a Laplace transform?" And this guy grabs a pencil and starts to do one, which is good Commodore attitude, yeah? So I grabbed the pencil out of his hand, and I didn't mean now, but I knew he'd been hired. So I give you, ladies and gentlemen, the 3rd act of a Greek tragedy, Commodore Part 3, What's Dead May Never Die.
Okay, so, yeah, Greek tragedy. Well, it was summer of 86 or so. Bill is leaving, if he hadn't left yet. I was trying to figure out how I was going to justify not also getting fired, because there had been rounds of layoffs. Commodore was a little sketchy at that point. They'd spent a lot of money buying Amiga. We hadn't seen any of that yet. So I was working with Frank Pelea on a couple dog and pony things, trying to figure out if there's any life left in 8-bit. And we had created there was, actually, Bill knew about this. There was an MMU that he wasn't allowed to use that could actually support 256. So I did a quick C256 hack of a regular C128. We got Freddie to support it in software. And then we had a different model that Frank worked on that made the Z80 go full speed. And we were proposing this as maybe something, and no, management really didn't know what they were doing at that point, and they had no idea. But so in parallel with all of this stuff, with Amiga getting acquired, there had been this other project called the Commodore 900, or as we called it, the Z8000 project. And there had been 2 different teams that really didn't get anywhere on it. But the 3rd team actually kind of did. That was George Robbins and Bob Welland and a few other people, a few software people. And the Commodore 900 had been Commodore's answer to essentially what the Amiga was, as a higher level machine, a 16-bit computer. This one was running an operating system called Coherent from a company called Mark Williams that was a Unix clone. And these were all Unix guys. And the Commodore 900 also had it had a graphics, megapixel graphics, had black and white screen that was running with a bit blitter chip that Bob Welland had designed and at least architected. And it was kind of a cool computer. It had a windowing system written by this guy Rico Tudor that was just wicked fast. It really didn't do much but let you have a bunch of different shells on the screen. It wasn't a full graphics environment, but it was wicked fast. And of course, because of the Amiga and Commodore's problems, the Commodore 900, which had been in development for years and finally got working, was canceled. So these guys had to figure out what to do. So they decided they were going to take on the Amiga. And so the Amiga 1000 was a little expensive to make because you had a lot of stuff. You had this Agnes chip and all these buffers around it and all these PALs to control the buffers because the chips themselves weren't fast enough to control the buffers. And it made it kind of an expensive system and kind of complicated. And these guys decided, hey, we can do better than that. And they came up with the fat Agnes concept. And that was going to suck all that stuff into a bigger chip, as the biggest chip Commodore could make at the time, 84 pins. Whoa. and so the people out in Los Gatos didn't think that was possible. It's not going to work. And in fact, they weren't even 100% sure it was going to work. All the timing said it should, but they were being very cautious. So they actually had a separate project where they had the fat chip, which was just the fat that you could put next to regular Agnes. But the fat Agnes worked, and so before you knew it, George and Bob were working on the Amiga 500, and I didn't really have anything to do. So in August of '86, they said, Dave, you're the low-end guy. Come and look at this computer that George has created, and you should probably take this over and let George go, and we're going to be taking over a project. So the German group, we had a smaller engineering group in Braunschweig, and they had decided, they had been working with some of our PC people to say we should build this Amiga that can run, that can expand to allow IBM stuff to run in it as well. And none of us were crazy about that idea, but they had this whole Amiga 500 concept, only they had really just taken the A1000 design, and they had taken some of the schematics that had been published for building backplanes, building Zorro backplanes, and they put them together in this box. And it wasn't terribly well thought out, but it worked. And then but they wanted more memory, so they had this really bad expansion memory that they had put a slot in there that was really just for this expansion memory. It was identical to the Edge on the Amiga 1000, and so we were going to be taking that over. So I was like, okay, I'll go in there, and I worked on the Amiga 500 for about a month, and it became pretty clear quickly that George just wasn't going to let that go because that was his baby, and so they put me on the A500. So all of a sudden, I moved to being like, I'm at like 23 years old. I'm like the high-end guy now. so I guess maybe I was 24 by then. But anyway, it was so I'm doing this high-end Amiga 500, and really, I was just following the A500. I mean, the Amiga 2000. I was following the A500. I was saying, okay, well, let's see what they do. And whatever George did, I did about a month later on the A2000. But there was some other stuff. So okay, so they had put a lot of internal slots to match the connectors on the Amiga 1000. So there was this slot for the extra memory card, and I said, that's kind of stupid. We don't need that because I'm going to put a whole megabyte on the motherboard because you can do that with Fat Agnes. So I decided that the one thing that was really catching on for the Amiga 1000 at the time was that people were putting CPU cards on the side. So I said, okay, we're going to turn this memory slot into a CPU slot. And we'd already decided that, again, with the expansion bus, that was a bunch of buffers and a bunch of PALs. And I wanted to at least get some of that stuff into a gate array, into a custom chip, to make the cost go down and also make it just, PALs are bad because you have to program them in production. So they're actually more expensive than you think they are because you have to have somebody putting the code into them, or you have to buy them with the company putting the code in it, which means you don't get the volume discounts that you want. So, and we were very, very sensitive about price at Commodore always because we wanted to be cheaper than everybody else and better in every possible way, and it worked out. But so anyway, let's see. So I was working on this, and I had decided that we should have the whole video bus. Not just this video slot they put in there was really just the Genlock slot. It was the same as the 23-pin connector on the back of the machine. And so I looked at it and said, we got to bring out the rest of we had this whole 12-bit video bus, which doesn't sound like much, but it's better than there are 4 digital bits that went to that, and then all the analog stuff. And I was talking to George about it, and he says, why don't we put some other stuff there, parallel port or something, so it can control whatever goes in there. So we just kind of cooked this up, and put a second connector in there, and we filled that second connector with the rest of the digital video and all the signals that could go there. And we didn't really know what you were going to use it for, but we figured it was probably a good idea. And so that was the Amiga 2000. A little bit after that, Bob Welland was still trying to get Unix on some kind of computer from Commodore. He had come up with an add-in card. We had actually been discussing this because of this whole CPU slot thing. He was working on a CPU, and he had come up with a card that had a 68020 on it, which was the big upgrade from the 68000. It was full 32-bit. This card could have 4 megabytes of 32-bit wide memory that would go really fast, and it actually had an MMU on it so you could run Unix, because that was his evil plan, was to run Unix. And that he was having trouble getting it to work. So when the A2000 was done, this is like 87 or so, I started getting into that, and it turned out that I was getting into it because Bob was leaving, and he left us for Apple. He was actually one of the main guys behind the Newton.
What kind of Unix was it?
It was before System 5 Release 4, so you had, I guess it was System 5 Release 3 or 2. It was System 5, and you had to, we called it AMIX because, of course, you weren't allowed to say Unix back then, and it ran the Rico Windows, it ran this really fast Rico Windows system, and you could actually run Unix on a 2 megabyte system, but if you wanted to run Emacs, you had to run 4 megabytes. I remember that because it was constantly swapping. It basically just thrashed the hard disk running Unix in 2 megabytes. And another kind, and so that was, the 2620 got working, and again, it was one of those like, okay, what do you do next? Well, now, Commodore for many years, we hadn't really been pushing that many envelopes. I mean, the 8-bit stuff, we made our own 8-bit chips, but they were, we were doing interesting things with them. The MMU was C128 was probably the best 8-bit system that ever went out. It was way more flexible than just about anybody else's, but I got a call from, Jeff Porter wandered over one day, and said, Jeff Porter was our director of engineering, and basically the guy who kept everything going and kept all the corporate nonsense away from us so we could actually concentrate on making stuff. And he came by and said, Motorola told me they're going to send us a 68030, which is this brand new chip that had the MMU built in, so you didn't have to add the second part and figure out all these double bus arbitration systems and everything. And we're going to have this in about a month, and that's all he told me. And within a week, I had redesigned the 2620 to support the 68030. But the other thing was that the critical thing here was that the 2620 got its clock from the Amiga 2000, and it ran at 14 megahertz because you had 2 different 7 megahertz clock that were phased differently, and you run them through an exclusive OR gate, and you get a 14 megahertz clock, and that was good, but I wanted to go faster, so I put a 25 megahertz clock on this and figured out how to synchronize the 2 buses so that it would go really fast. And talked to everybody we had this guy Terry Fisher who's like just the wizard at putting out circuit boards. So I was like, Fish, I got this new chip. You take that old design and change all this stuff around and crank this out as quickly as possible. And when that 68030 came in, I plugged it right in on the other side of the board because somehow the top and bottom of the 68030 pinout was wrong. But fortunately, in the days of through-hole chips, you just put it on the other side of the circuit board, and it would work. So that's what I did, and I had the 68030 system, and probably several sleepless days later, judging by the number of jumpers I remember putting on that thing, it was up and running. And I put a label on it, said world's fastest Amiga, and went home and slept all weekend. And then the next week, I had come up with this memory system where the 68030 also had this burst mode that was really cool. You could run a lot faster if you ran in burst mode, but you basically had to get memory going really fast. So I had this memory interleave using the memory zone output buffers and made it go in burst mode, and then it was running I was just running all these Drystone benchmarks, and this went even faster than before. So I put a sign on it that said the world's even faster Amiga, and let that run for a while, and then I realized that the memory chips were actually kind of destroying themselves. They weren't really fast enough to be run that way, so we didn't ship with that particular memory configuration, unfortunately. If you stuck around long enough, you got a memory type called EDO, which actually did that correctly, because you could turn off part of it, and it actually had a higher speed buffer in it. And it also, that buffer latched the data, so you could kind of start the next memory cycle. So a couple years later, it would have been possible, but it wasn't possible then. Another interesting thing happened in the mid-'80s, and that was there's this guy Hedley Davis that we hired, and he was kind of a mad wizard. He came up with this idea for, Commodore. We were really always hoping that we were going to get better graphics chips, but the custom chips really complicated, and you needed, it costs a lot of money to make new custom chips, and Commodore wasn't much about giving money to engineering anyway. We did a lot with what we had, probably got our best return on the money, on money spent for any company doing personal computers, but they didn't spend enough money. So Hedley had come up with this neat idea of, if you made a smart monitor with its own memory, and then just sent different parts of that image over the Amiga video, you could come up with a higher resolution. And it just turned out that if you did things with the copper and everything, it all kind of worked, because you could, with the original chipset, you could have a screen up to 1008 by 800 that could still blit. And if you got the ECS chips, you could actually go to 1024. So Hedley came up with these monitors that did 2-bit color, or 2-bit grayscale. So it was black, dark gray, light gray, and white. It just so happened that we had gotten one of these Next cubes, because we were always, almost any time somebody came out with a computer, we'd get it in and take it apart. But the software guys liked the Next cube so much because of it had the nice big megapixel display with 2-bit grayscale, that they wouldn't let anybody take it apart. They wouldn't let me anywhere near it. I mean, I had taken apart we had Radio Shack computers I took apart, and part of it was just to steal their really good manufacturing ideas, and part of it was to laugh at how bad they did stuff, like they had capacitors hanging all over the place, and blue wires and green wires and all this stuff in production units. We weren't buying their prototypes. You got to feel superior in some way, and it wasn't our sales or our marketing department that made us feel superior. So, he had come up with this monitor, and pretty soon I got one on my desk. All the software guys were getting these, and that's a lot of what drove the look of Amiga OS 2.0, was to look really good on the Hedley high-res monitor and to steal some of the good ideas from what you saw in the Next operating system. We didn't want it big and heavy as it was, so the other thing that the Next didn't really inspire, but we were working towards that anyway. So around 1989, we started thinking about we had the Amiga 2000, we had the 2500 series. So we had the one with the 020 in it, the one with the 030 in it. But we wanted to go next generation. Now we got to build a real 32-bit computer. So we started on the Amiga 3000. And you just sort of knew what the name was going to be. I mean, it wasn't that hard to add 1,000. But this was actually a big project. Rather than just like one or two guys, there was, there was myself, Greg Berlin, Hedley Davis, Scott Schaefer, who am I forgetting? Jeff Boyer. And each of us had at least one chip to do. So I did the Buster chip. I knew about the expansion bus. I'd actually, in the summer of '89, seeing that stuff was going to happen soon, and I'd been reading about the eISA bus, which is what the IBM got, IBM compatible people had come up with for how do we expand the standard PCAT bus into something 32-bit. And I looked, and they came up with this double-level connector, and it got really complicated, and they still weren't doing auto-config right. They actually had a ROM or flash ROM or a EEPROM on the card that set the jumpers. It's like, you guys are still like 2 generations behind. But I wanted to keep things compatible as much as possible. So I figured out how to basically put a 32-bit bus on top of the 16-bit signals that we had, 16/24-bit signals that we had. And I made up this thing called the Zorro 3 bus. And the idea really was that I kind of looked at this as a generational thing, that we weren't really going to be able to do a great job of this for the Amiga 3000, but in the future we'd have an integrated chip, because again we were limited to 84-pin chips because that was the best Commodore could do, and you couldn't fit a multiplex 32-bit bus in both directions going through that. So I still had a lot of buffers there, and I actually did have a PAL, but not like lots and lots of PALs. I had to have something that sat on the expansion bus itself and did some memory decoding. But the concept worked out pretty well, and I scrambled around to try to find anybody to look over the stuff I had come up with to make suggestions, and it's really hard to get anybody to look at that stuff because nobody cared about the expansion bus except me. But I got Headley Davis to look it over, and he made some good suggestions, and eventually we thumbed up that, and we started working on the Amiga 3000.
You said you were doing chips for these?
Yeah, we were doing gate arrays. We were doing logic level design. Okay. It wasn't register transfer. It wasn't a high level language anymore. We were doing all the systems guys were doing some sort of gate array. Commodore had come up with a gate array process. We originally had a thing called the channeled array, and then they switched it to a sea of gates, which didn't work very well for a couple of years. But so they had what we call a custom chip is a full custom chip, the typical one. That means that means that there's a custom layout. They're designing things at the transistor level, and that's not what this is. This is where you basically just design the logic, and it goes into a standard chip. It's like a big programmable chip, only it's not programmable. They could crank one out in a month, which was kind of nice because most companies can't give you a new gate array in a month. And you could do fairly good stuff. We were running at 25 megahertz, which is about the most that these things could handle, and you had to be pretty careful about them. They weren't that fast, but it worked. It worked.
What were the chip guys? Were there chip guys still, or were they?
Oh, there's still chip guys. The chip guys were actually working on some future stuff. They really didn't do for the Amiga 3000. The chip guys gave us a version. I sat down with George and some of the chip guys, Bob Rabel, and I kind of told them how I wanted the memory, how I wanted stuff to go. Oh, Greg Berlin was there too, and we decided kind of on how we were going to architect this. Because the thing about the Amiga 3000 is we were still using the 16-bit chips, but we wanted to have a 32-bit chip bus, so we had to make sure that would work pretty well. So when Agnes hits the memory, it acts like 16. When the A3000 talks to chip memory, it acts like 32-bit. And that worked. It was good. We also had Unix. The Unix guys were still around. Not Rabel, not Bob Wellen anymore, but Johan George and Rico Tudor were porting Unix. And in fact, we were now actually allowed to call it Amiga Unix because when they made agreements with Sun, and they started trying to make Unix more of a one thing and not just like everybody's special own little Unix. Kind of ironic that didn't work, but so anyway, we were presenting in 1990 in April. We had this big thing in New York City to present the Amiga 3000 to the world. And we did. It was at a place called the Palladium or something like that. It was a really cool show. Biggest debut for a machine I'd ever been at. I wasn't at the Amiga 1000 debut. I hadn't been doing anything for Amiga 1000. So this was April 1990. And actually, the thing was the hardware had been done for a pretty long time. We were still making some last-minute revisions. I'd run into a situation where my Buster chip wouldn't work with the bridge card. Our boss, Vice President of Engineering, Henry Rubin, had really pushed this bridge card, the thing that lets you run IBM PC programs, and it had been designed in Germany. And I remember specifically this one day where, the bridge card wasn't working with the new Buster chip, and Henry Rubin was he was very, very panicky, and he summoned the Germans. I was like, give me a day, because the chip had just come in that day. He's like, give me a day. He's like, no, I'm summoning the Germans. And I had to go, I remember, I had to go and get a root canal that day. So I couldn't stick around. The Germans weren't even going to get there until later. And I had to go and get a root canal. So I went and got the root canal. But while I was driving there, I realized what the problem was. I'm driving down, I had this stupid Fiero at the time. I was going like 90 miles an hour down the highway. And I'm thinking about it, and all of a sudden, like, I know what the problem is. So I went and got my root canal. I came back. Germans had apparently arrived. They saw that nothing was going and went out to dinner. And I wasn't there, of course. So I'm there at like 9 o'clock at night. And I made this little fix to, I think actually I put it on the back plane of the Amiga 3000, the riser card. And the problem was that it was the ready signal versus the OVR signal. It was the way you controlled DTAC. And the Buster chip was doing something that they hadn't thought of. And I'm not sure, you could argue either way, whether I was wrong or they were wrong. But it was something that clearly had to be fixed in the Buster chip. So I fixed the back plane. And then immediately, bridge card came up, it was running, and MS-DOS. And I put a little shell script in there that just looped and said something, I don't know, something pithy. And then I went home. Now, these guys had no idea I had even been there. So they get back from dinner or whatever. I don't know when they came in next. I didn't come in the next day. I was really beat. And it was just working. And like they had no idea why it had started working. So that was kind of the way things, I always like doing things like that because they know some mysterious man comes in and fixes things.
So would you rather have had a root canal or meet with the Germans?
The root canal, yeah, the root canal was actually, especially the Germans who were working on the bridge card, it was just, I mean, because I didn't like the idea of the bridge card because it was kind of stupid to run IBM stuff when you had an Amiga, but that was just me. So anyway, so we're debuting the Amiga 3000, and the one thing almost nobody knew about was 6 months before that or so, we had hired this guy, Scott Schaefer. Now, the 68030, of course, was in the Amiga 3000. That had been around for a couple of years, right? Because I'd gotten one in '87 or '88 when they first came out and made the 2630. Well, the thing is, the 68040 had been announced. It was coming out. Almost nobody had one, but we hired Scott Schaefer to make us a 68040 board because I'd been busy on other stuff, and I'd been usually the guy who did CPU boards, right? But he actually had 68040 experience already. We had a kick-ass 68040 board at the Amiga 3000 debut in 1990. It had like 128K L2 cache on it, or was it 256? I don't know. It was a big-ass L2 cache on it, and it was a very, very expensive thing to make, but it was super high power. And we told Motorola that we had this and we wanted to show it at the thing, and they were like, we have to get special permission. We can't let you show that because no one had ever shown a 68040 in public before. And they not only got a special permission, they had a courier take a golden 68040 chip for us to show off because they were all worried about some of the errors they knew about, none of which mattered to Amiga OS anyway. Or our guys had programmed around them or whatever. I mean, they tended to do that. We worked at Commodore. You never really expected your chips to work right anyway. You just so we did this thing. We had this there, and our bosses at the last minute said, "Nah, we're not going to show it." So it was big. You had this balloon. It was finally ready, and then, they let all the air out. So yeah, that kind of sucked. But
who was it that said you couldn't show it?
I don't even remember. I think it came from Henry, but I'm not sure who made the final decision.
Like Marshall Smith, was he still there?
No, okay. No. And no one was around to punch him, so.
That's only a rumor.
Okay, so the last bit of the Amiga 3000 era was about a year later, 1991. The Amiga 1000T came out. That was mostly Scott Schaefer and Greg Berlin working on that, and that was the tower version. And the main thing there was we were trying to start to get to more standard parts. So they were using a more standard power supply in there, something that was more PC-ish, and part of the problem was, to make Amigas cheaper, we didn't want to keep reinventing wheels that were already pretty good. We just wanted to concentrate on the stuff that only we could do. So that was really the impact of the Amiga 3000 as far as I was concerned, was that it was just it was going to make things a little more standardized. So at the same time as the Amiga 3000 was coming out, the chip guys were working on, okay, so there was, everyone's like, what are these chip guys doing? Well, in 1988, they started on this project called the Advanced Amiga Architecture, or AAA. That was a really long multi-year project that was building us a 64-bit graphics chipset. And it was taking a long time. And of course, Commodore wasn't spending enough money on engineering. And the most expensive thing you can spend money on is chip design. So that was not going really fast. In between that, George Robbins had been talking to Bob Rabel, another chip designer, and they had come up with this thing that was originally called Pandora, and eventually got, after AAA, this became AA because it wasn't quite as big as AAA. I guess a AA didn't actually stand for anything. It was just one less than AAA. They could have called it Triple B, I don't know. But anyway, so AA, and I got involved because they needed somebody to build a computer that would take these chips. They were coming out in late 1990. So pretty much right after the Amiga 3000 was done, I started working on what I called the Amiga 3000 Plus. That was something I cooked up with Jeff Porter. So it was going to take the AA chips, which really weren't hardware-wise what I had to do. There was different stuff, but it wasn't crazy different. It had a 32-bit bus for video fetch, and it could do burst mode. It could run 2 cycles. For every RAM cycle, you could get twice as much data. So you got basically four times faster, but just for video modes. The Alice chip was really just a revised version of Agnes. It wasn't going to be doing anything, and we didn't have Paula was still Paula. We didn't change anything there. But it was going to give us 8-bit color. It was going to give us better graphics modes, and we really needed that sort of thing. And it was going to let us talk to VGA monitors without a flicker fixer. So, but the Amiga 3000 Plus, I'd been a musician. I really didn't do much of that during Commodore, but I'd also been an audio guy, and I just wanted better sound. So I was like, I talked to Jeff. It turns out we were approached by AT&T about this thing they had called the DSP3210, which was a DSP chip, and Next had a DSP chip in their system, but this one was different. This didn't sit on a port with its own memory. This sat next to the CPU as a coprocessor and could access anywhere in memory that your 68000 could. So I looked at that and said, "Well, that looks good." And Jeff is a communications guy. He had been working at Commodore. He worked at Commodore, and in about 6 months had come out with the 1200 baud modem. Really fast product delivery for a guy just starting at Commodore. So he was a communications guy, and guess what? You could also do with the DSP. You could do modem stuff, and that's kind of what we thought about it. There was another thing that had, it's kind of sad to point out, but the DSP3210 did 32-bit floating point 10 times faster than the 68040, which might have been useful to graphics people. I don't know, but all these people rendering stuff on. So Amiga 3000 Plus was also going to have an 040 in it. So I started working on this. I had the DSP stuff going. We had Randall Jessup and a consultant from outside, Eric Levitsky, working on the AT&T chip. Actually had its own operating system. It was called VCAS, and it was designed almost, if you wanted to sit down and figure out how to put a DSP on the Amiga, and you knew everything about Amiga OS, nothing about anything else, this is pretty much what you would have come up with. It was perfect for us. So we built this thing. Greg Berlin was redesigning the DMA chip at the time, the SCSI chip, the one that Jeff Boyer designed, because there were some issues, and he wanted it to go faster. It didn't go fast enough. And so I got him to put some DSP control stuff in that chip, just at the last minute. Unfortunately, just at the last minute meant that my stuff got connected to the wrong bus and it didn't work. So the prototypes, we only had a couple Amiga 3000 prototypes that worked with the DSP, and they had all kinds of PALs and nasty wires around them, but they worked. And Eric had one and Randall had one. I never got one. But the DSP stuff worked. There were two different audio codecs on there. One was for hi-fi audio. One was for modems. And the modem had to have some sort of phase correction stuff so that 9600 baud would work. And the real key was we went to AT&T, and AT&T didn't even understand what we were going to do with this. They thought, we're selling you a DSP chip and some software to replace a more expensive piece of hardware. We went there and told them, no, you're selling us this DSP chip to not replace anything, to sit next to our CPU, and we don't want to pay anything for the software. of course. Well, we negotiated, and basically they were going to give us a bunch of math libraries so that people could write applications. And this thing multitasked, by the way. It didn't, you know, it was a different. It was multitasking for DSP is a little different, but it multitasked. Wasn't like the next chip at all, and we were going to get almost everything, including up to 2400 baud modem, in that package, and then we could sell other stuff. They had some of their special sauce stuff they wanted us to pay more money for. So fine, those would be add-on software packages. And this was going fine until, and then there was one other computer that we were working on. There was this guy, a junior engineer, Joe Augenbraun, who had come up with this idea that everybody loved, to finally get a mid-range computer going again. So we had A500, we had A3000. What goes in between? Well, there's room for something in between. So Joe had come up with this thing that we started calling the A1000 Plus, because it was going to be a 68020 processor. It was going to, this is in like 1991, 1992. It was going to run, it's going to have its own kind of CPU slot, so you could expand it a little bit. It was going to have a little bit of fast RAM built in. It was going to sell for under $1,000, which, if you know, Amiga 2000s were, you know, $2,000 or $3,000. So it was good placement. And then, kind of, the shit hit the fan. Let's put it in the proper terms. Well, you know, our chairman of the board, Irving Gould, was never really happy with much anything Commodore ever did, other than pay him $3 million a year. So he went looking for people to blame, and it was usually the marketing people. And you know, if they weren't selling enough, that might mean something. And you know, it wasn't like they came to us and asked for hardware that we couldn't deliver. We usually asked them what they wanted, and when they had no idea, we gave them something. They came, you know, so he came and basically replaced Henry Rubin as the head of engineering, and with this guy Bill Sidneys, and Jeff Porter was sort of pushed out of the way, and they brought this other guy, Jeff Frank, in to be the director of engineering. And their mission for the first 6 months was pretty much to make the Henry Rubin, Jeff Porter administration look bad. They didn't have really a whole lot of other plans, other than there's this A600 concept. Okay, so after the A500, George Robbins was working on some additional, they had a couple versions of the A500. Eventually he decided he wanted to make something that was even cheaper. So he had come up with this idea of an A300. He had this really brilliant hack. I don't remember how it worked, but it was going to have a built-in Genlock. And it was going to be like, the Genlock was going to cost almost nothing. And it was lower priced than the A500 because it was going to have, it didn't have built-in drive. You had to add on a drive, and you could, but by then you'd have the option of adding on a hard drive or a floppy or both, or a CD-ROM or whatever, because those things were all coming up. And they took this A300 design and started adding all kinds of crap to it, and eventually came up with the A500. That's why it had the IDE slot, or no, the PCMCIA slot on it, a few other things. It was supposed that this project, whatever it was supposed to be $50 or $100 less than the Amiga 500. Turned out to cost $100 more than the Amiga 500. And our friend Bill Sidneys, not delivering, was fired over this. The biggest mistake they made at this time was that the Amiga 500 was canceled, even though it was still selling really well. I mean, it wasn't the most current thing, but the problem was the Amiga 600 didn't give you anything you didn't get with the Amiga 500, except that everything was soldered down inside, so people couldn't hack it as easily. And everybody loved hacking Amiga 500s. You couldn't, the CPU wasn't in a slot anymore, and it had this memory card add-on thing that nobody knew what to do with anyway, because there were no drivers, plus it didn't support the full PCMCIA that they wanted. So it was kind of a boondoggle in that they cut off this one machine that was selling really well and replaced it with something that nobody wanted. Okay, so the other thing that happened was now they sort of liked the idea of this mid-range computer, but they didn't, I think Joe had already left by then, after the A1000 Plus was done. So they decided they were going to make a stripped-down Amiga 3000. Greg Berlin was responsible for this. Greg and Scott Schaefer were working on this, and it was dubbed the Amiga 2200 or something like that. We all called it the A1000 Junior because the thing about Bill Sidney, he had worked at IBM, and he was the guy responsible for the IBM PC Junior, which at the time had been their greatest failure in like the entire history of IBM. I'm not sure they had a better one after that, but up to that point, that had been their greatest failure. So everyone called it the IBM PC Junior, which I'm sure just rubbed him the wrong way. But I mean, we called it the A1000 Junior. So there's this weird thing about Commodore. So this was actually built, and there's this weird thing about Commodore that it's the sales companies decide what they're going to sell all throughout the world. And if they don't order something, it basically doesn't get made. And not a single one of them ordered an Amiga 1000 Junior or 2200 or whatever you want to call it. There was a big brother to that called the 3400 that had the regular configuration of the Amiga 1000. It was, I mean, Amiga 3000. It was in a different case. I don't even really know what it was for, other than it was basically an Amiga 3000 with the SCSI taken out.
Wasn't there a memo or something that said the next person that calls it the Amiga Junior is fired?
I don't. There might have been. I never pay attention to that stuff, but but there might have been. So anyway, actually I have it written down here: Amiga 1000 plus stupid equals Amiga 1000 Junior. Amiga 300 plus stupid equals Amiga 600. That was my notes. So actually what happened was, the A3000 Plus, some of the A3000 Plus stuff was going into, now that they realized that nobody wanted another ECS machine, which is what the Junior was, the A3000, A3400, whatever they're going to call it, got AA and became the A4000. While Greg was working on these lesser machines, he told Scott Schaefer, build us the cheapest 040 card known to mankind, because he's like, we really can't release another 030 based computer. So he was at least going to have an upgrade in mind that didn't cost a mint like this really good card that we made. So they built that module, and those two pieces, the upgraded 4-slot machine. The upgrade was adding Zorro 3 and a few other things that made it a little bit more like an A3000. And then that 040 card, and it had the AA chips and all that, and that became the Amiga 4000. And so to put it in perspective, the A3000 Plus first booted in graphics, with graphics working and everything, in February of 1991. We were hoping to ship it probably within a year. The actual shipping of the Amiga 4000 was fall of '92 because of all this delaying and screwing around with things that nobody wanted, and everyone in engineering knew that nobody wanted. Even the people working on it knew they didn't want it. They did their best, but if you're making the wrong thing, you're just making the wrong thing. The one good thing that was happening at the time was George Robbins, Brian Fenimore, and some other guys were working on the Amiga 1200. And mostly because, for whatever reason, management had been concentrating so much on doing the high-end machine wrong, they weren't paying too much attention to the low-end machine. So that was done pretty good. The 1200 was a great design. They actually did a whole gate array Gale that did kind of everything you needed to do. It was what Gary did, only it was more so, because they were actually allowed to do it outside of the company, and they had a bigger package. So these both came out in 1992. There's some other stuff that was going on in the Amiga world and everything. So in 1990, this little thing called the Video Toaster came out. And it actually came out for the Amiga 2000, because nobody, of course, knew that the Amiga 3000 was coming, and you could kind of squeeze one into Amiga 3000. It didn't always work that well. But the Video Toaster was really starting to revolutionize video. And if you looked at almost any cable network, if you started seeing this stuff show up on, you started seeing, Amigas were being used everywhere, but they were starting to not look like Amigas because the Video Toaster was making things look very professional. If you look at anybody in this room with a camera that costs more than $4,000, they were probably Amiga Toaster users at some point, and maybe even some of the others. And the Amiga Toaster also, the Video Toaster also delivered in 1993 Babylon 5, which debuted with 20 minutes of CGI in an era when nobody did much CGI for television. And the other one, actually the same year, was Sequest DSV. Those are both created because there was an Amiga that could do that sort of thing. So things were actually picking up. Video was becoming this really critical thing that Amigas did that nobody else did. So, the Amiga 4000 stuff didn't change a whole lot of that. People like the Amiga 4000 over the 3000 because it rendered stuff a whole lot faster because of the 040 in it. And they didn't really, the architecture wasn't what I wanted, but they didn't care that much because when you're doing rendering, it's almost all the CPU, and the I/O and stuff didn't matter that much anyway. But I was looking for the next thing. So in 1991, I started designing what probably would have been the A5000 system architecture. It was something I called a Cutiator. And it was, I had come up with a bus that was sort of a processor-independent bus that was going to connect all these modules together. And then in 1992, I mean, this was just stuff I started designing. I didn't actually write circuits. I was designing the whole architecture first while I had some time, waiting for all this stuff to settle out about the Amiga 3000. Plus, what we were going to do with AA. There was just a lot of downtime where they were delaying things. So I was working on the next thing, figuring out, I got to do something. And then PCI came along, solving exactly that same problem. So AmiBus went out the door, and PCI came in and replaced it. Let's see, I had also designed because of the A4000 not having really fast SCSI, I designed a Zora 3 thing called the A4091 that had the best SCSI chip we had ever used on it. And we actually licensed that out for somebody else to make because Commodore wasn't doing so well, and we were a little concerned about biting off more than we could chew anyway. So I just designed that, and we were able to license that out to a third party who made it, and it was the fastest SCSI we had until the other thing that came out a little bit later was the Amiga 4000T, which was an Amiga 4000 with that SCSI chip in it and a few other corrections, 2 video slots, a few other cool things, but Commodore's in such bad shape by then, that was 93, that things were really, they just couldn't make many of them. It's kind of a collector's item, I think, these days, but that was the best SCSI we'd ever had in the system. Let's see. Okay. There was this. Remember, I mentioned in 1988 there was this thing called AAA that was working, or that started working on. Well, in about 93 or so, they were actually getting chips back. So they contacted me again and said, you got to make a board for these. So I created a motherboard using A3000 parts and a whole lot of really fast PALs that was called NICs. And so it could support either a 32-bit or a 64-bit AAA system. AAA could give you graphics up to 1280 by 800, something like that, in various different color modes. It had crazy amounts of color modes. It had some compressed modes that would essentially expand kind of like some of the early video compression, only in hardware. It had full line buffering for every line, so it could support 4 different pixel clocks at the same time, so you could do the pulling up and down of screens. It had a 32-bit copper, a 32-bit blitter. It had some 4 operand operations with blitter. I don't remember what it did. It was a lot of stuff it did. It was pretty amazing. It didn't work. Well, I mean, we had first rev chips. We put them into this system that was highly hackable, so I could basically reprogram almost anything to make it work. Only thing I couldn't do was the original Andrea chip didn't have a bus that turned off properly. We really couldn't fix that. We did get graphics out of it with some peeking and some clever stuff. We had a couple, they found a couple errors in the chips, and there's this process called fibbing, focused ion beaming, where you're basically making edits to an existing chip. It costs about $1,000 per chip. So they fibbed a couple of the parts to do what we wanted them to do well enough to actually get images out. There was something wrong with the color lookup table, so you actually had to do a mathematical transform on your RGB to then put that in. I mean, it was exactly what you'd expect for a very first rev of the chip. Only problem was that was also the last one that was ever going to happen. It was pretty clear by then. So that's one of the other things that just never, kind of great idea. It was too late. It should have been 2 years earlier. If that came out in 1992, it would have been the best graphics on any machine that you could call a personal computer. Let's see, there's a few other ones here. CD32 came out in 1993 as well. That was basically an A1200 scaled down to be a game machine. That was really well done too. They had actually integrated the 8520s into a custom chip. It was a neat process. A lot of people do that now, but they were one of the first ones to get a really, really, really expensive FPGA, like maybe 500,000 bucks, and put the whole 8520 design into that. And then they took out the parts they didn't need for the CD32, built that as a register, as a high-level language model, and then moved that over to the custom chip, and it worked. And that was pretty much the last act in 1993 into 1994. CD32 was a popular idea. Commodore was in such debt that they were paying cash pretty much for anything because they owed people so much money that they couldn't get any parts unless they paid cash. And of course, they weren't getting parts at really good prices because most of the people who were smart enough to to see all the bills Commodore hadn't paid weren't even interested in talking to them. So the CD32 orders, the A1200 orders were like many, many times what they were actually able to make. And of course, the whole thing came crashing down in the spring of '94. And there's somebody made a film about that. And yeah, that's the end of Commodore. I mean, I didn't want to dwell too much on the things coming down, but we had Amiga OS 3.0 was out for the Amiga 4000. They were working towards retardable graphics that was going to let you run graphics on any graphics card as part of the operating system. That was another thing that Commodore hadn't spent enough time and money to make that happen early enough. That was another thing that was going to make things. I was actually at the very, very last few days, I was working on a thing that was going to. I was working with a company, actually a local company in Pennsylvania called Sang Labs that made one of the early VGA, better than VGA chips, and they had some unique properties to there. They had a really, really fast PCI bus interface. So I was going to be able to basically use that as either a graphics chip or a flicker fixer. I had a PLD design that was going to basically allow that thing to act as a flicker fixer, take video directly into it, but also turn it into a frame buffer and a smart thing. Once retardable graphics were working, that was another thing that there just wasn't enough time to finish. So that's pretty much it. That's the last few years of Commodore, and that was the last 9 years. I mean, some people thought that that after the 8-bit stuff, Commodore's really headed downhill. But for a long time, there was an upward trajectory. We were getting into things. The gaming in Europe and the video in the U.S. were really taking it in new directions. And anytime we came out with a new model of the high-end stuff, the same people went and bought the same one. So we had a guaranteed 150, 200,000 unit sales right off the bat, and the Amigas in Europe were selling, I think they sold 1.5 million at the peak in 1 year. So it wasn't like they weren't trying. I mean, it's just you have to spend money and put it in to keep things going, and otherwise you fall behind no matter how diligent your engineers are, because we work on adrenaline and coffee and stuff, but we can't, some things actually have to be paid for. I can't just I can't 3D print my chips. If I could, maybe Commodore would still be around. But anyway, that's all I got to say about that.
The Commodore 65 was that fitted in somewhere in that time frame as well.
There's one in every crowd.
We don't talk.
Got to stick it in, haven't we?
Nobody understands why there was a Commodore 65, other than there was a guy nobody wanted to work with, and they kind of let him do whatever they wanted, whatever he wanted to do in order to not have to work with him. There was absolutely no possible reason on this planet why there should have been a Commodore 65.
I heard that Apple invented the home computer.
That's false information.
So I was wondering, while you guys are doing 1000s and 500 pluses and 3000s and dithering this and all that, what was Apple doing?
Apple was making Macintoshes. Apple was the big beneficiary of the whole thing we did with AT&T, because even though the Amiga 3000 Plus didn't work, it didn't get finished, didn't go out with the DSP in it. A year later, Apple went to AT&T asking about DSP chips, and AT&T, because me and Jeff went to AT&T in Allentown and told them how they had to sell this to us. it was all set when Apple got there. AT&T already, they had already been schooled. They are, I'm sure they charged Apple more than they charged us. They probably got $10 a copy for that math library, but they were already being told, they had already learned how to sell this stuff. So Apple got that, and Apple, they even came out years after the Amiga 3000. They even came out with an OK 68030 line product called the Mac 2 FX. The only problem was none of the good stuff ran under Mac OS. You had to go to Unix to use the DMA for hard disks and things like that. So Apple was still way behind. They got fairly good hardware about the time they switched over to x86, mainly because they weren't really designing anything anymore. It was just an off-the-shelf Intel chipset.
Dave, what was your opinion of the CD-TV and Carl Sassenrad?
Carl's another one of those mad wizards. I have a lot of respect for Carl. And the CD-TV was a good idea. I actually probably should have put that in there too. But CD-TV was, that came out in 1990 or so. The CD-TV was, it was actually, the thing I liked best about it was it really pissed off Philips, because they had been promising this thing called CDI for years and not delivering it. And in one stroke, we beat them to it, even though they had been designing it for years. I thought it was a great idea. They did it right. A lot of the things that you want in a personal computer, you have to do different for a living room appliance. And even back in the Commodore days, we had poked around the idea of, we had a lot of really good ideas. We had this. This guy Terry Ryan had a thing called the PIM, which was a little bit like one of these, only with the CD that you'd carry around and have all your information with you. And we had some ideas for living room computers, but we could never quite figure out exactly what to do with a living room computer. But the living room computer became a big thing, because that's all your game machines now, really just living room computers. I did some living room computers at companies later on, but the CD32. CDTV, CDTV Plus, that was kind of the first living room computer. That was a real full-fledged computer that you thought was an entertainment appliance. So it was a great idea. Time?
Jeff, do you have a question?
I was going to ask what was going on at Atari at the same time, because Jack Tramiel had gone there.
Who cares what's going on at Atari? Actually, the interesting thing about Atari was that the Atari ST was an awful lot like Rev 2 of the Z8000 machine, and it's hard to imagine how that could have happened. The interesting thing, of course, was that the Rev 2 of the Z8000 machine didn't work.
Well, we couldn't prove that it looked like it because they shredded the schematics before they left, so we actually didn't know what a Rev 2 looked like by that time.
So they copied something that didn't work?
Well, they got it to work, but I mean, they basically walked out of the door with a particular architecture that just magically showed up later with the 68000 in it. You can't really prove that happened, but everyone knows it did.